Yes. Okay, so we're moving into solving rational equations. We did not spend a whole lot of time last year in Algebra 2. We did not spend a whole lot of time the previous year either because of COVID. So this may be a little bit more of new than review, even though if it was a regular past 2 years, it would be a review. But we've had some hiccups and bumps along the line since then. So bear with me and stay open-minded. So when we solve rational equations, the reason why they're called rational equations is because there is a variable in the denominator, okay? You have a variable in the denominator. So if you look right here, this is a rational equation. Why? Because there are what? Variables in the denominator. This is a rational equation. Why? Because there is a variable in the denominator. That's what makes it a rational, okay? The numerator and the denominator are, for this unit, they're going to be linear equations. However, once it's in the denominator, it now goes from being a linear to a rational situation, okay? There's a difference. So if the problem here said x plus 1 over 3 equals x minus 1 over 2 plus 7, this would still be linear. And the reason why this would still be linear is because the variable is not in the denominator. Can you see that? Cool. All right. So how to solve rational equations. So the steps that we follow to solve rational equations is 1, we factor all the denominators. For this current unit, they should already be factored for you, or it should be a simple factor, okay? 2, we find the least common denominator. 3, we multiply each side of the equation by the LCD to cancel out the denominator. 4, we solve the equation. And 5, we have to check our solutions because we want to make sure that the solutions we get do not make our denominator equal to 0. Okay? The reason why is that is because it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. Okay? Okay in the numerator, no-go in the denominator. Okay. So here's our first problem. We have 4 divided by x minus 2 equals 1 divided by x minus 1 plus 7 divided by x minus 1 times x minus 2. Okay. So step 1 told us to do what? To make sure everything is factored, right? So step 1 is to factor. And where I told you that this is not what this unit's really about, so it's going to already be factored, right? Until tomorrow. That's when we talk about factored. But 1.2, they're going to be factored. So we're factored, check. Step 2 is to do what? Find your LCD. So we're going to find our LCD. So your LCD is what is the least common denominator you can have. When it's in factored form, your LCD is just your factors. So when I look here, my LCD is x minus 1 and x minus 2. That's my LCD. Because those are my 2 factors in my denominator. Step 3 is to multiply each term by the LCD. So we're going to multiply each term. Okay. What this is basically saying, what is that term missing in order for the LCD, in order to look like the LCD? So when we look at the first term here, we have 4 divided by x minus 2, right? So 4 divided by x minus 2. In order for this to match the denominator to match the LCD, what is it missing? X minus 1. And mathematically, if I change one aspect of the fraction, I have to change the other. So I have to multiply the numerator also by what I did to the denominator. Okay, So now we're on to 1 over x minus 1. What is the denominator missing to match the LCD? X minus 2. So I'm going to multiply the denominator by x minus 2. And when I do to the denominator, I have to do to the numerator. And then the last one is, do I need to do anything to the last term? No, because it already matches our LCD. When working with fractions and you're adding and subtracting, as long as the denominator is the same, all you do is focus on the numerator. So now I'm in the position where all I'm doing is focusing on the numerator. So that all that matters now, because all of my denominators are the same, is to focus on the numerator. So I'm solving. So we solve the numerator. So we have 4 times x minus 1 equals 1 times x minus 2 plus 7. And now it comes back to being a linear equations with a variable on both sides. What do I do here? I distribute. So we have 4x minus 4 equals 1x minus 2 plus 7. Combine like terms. So we have 4x minus 4 equals x plus 5. After I combine like terms, I'm going to add 4 and I'm going to subtract x. Agreed? Is it okay if I kill 2 birds with 1 stone? So I'm going to subtract the x and add the 4. This is going to leave me with 3x equals 9. And then divide by 3. X equals 3. Okay, so what changed from examples 3 and 4 to example 5 is the LCD. So before I can do anything, I have to acknowledge what is my LCD, make those changes, and then solve as I normally would. Does that make sense? Okay, so that's the difference between a linear equation and a rational equation. Okay, so let's talk about this one. So here, oh, sorry, I didn't check. So last check, you can have a no real solution situation. So we end up with x equals 3, and we have to check x equals 3 before we say, yes, that's my unique solution. If I have x equals 3 and I plug it into any of my denominators, will it cause it to equal 0? The answer is no. 3 minus 2 is 1. 3 minus 1 is 2. So this is why this is my single unique solution. Okay? All right. I almost forgot. 5 is check. We'll always check the denominator. Make sure it's still rational. All right, so we're going to repeat it again. So step 1 is to make sure you are factored. Check. Step 2 is to identify your LCD. What are the factors in my denominator? X minus 2. So my LCD is simply x minus 2. Step 3, I'm going to multiply so that my LCD is in all of my denominators. Well, this one's good to go, right? X minus 2 is there. This one is not. So the plus 1 is going to have to become x minus 2 over x minus 2. Because anything divided by itself is 1. Okay. And then the last one is also good to go. My LCD is in my denominator. Okay. Now that I have all the same denominators, what do I have to focus on? The numerator. So now we're going to solve the numerator. So we're going to solve the numerator. So we have 2x plus x minus 2 equals 4. That gives us 3x minus 2 equals 4. Add 2 to both sides. That gives us 3x equals 6. Divide 3. And we get x equals 2. Step 5 is to check the value in our denominator. So check. In step 5, we check. If I was to take 2 and plug it into my denominator, what happens? I get 0. Oh no, womp, womp, womp. So what this means is that this is an extraneous solution. So therefore we have no real solution. Okay, do y'all remember asymptotes? That word? That's what that means I have, right? I have an asymptote, an imaginary boundary line that this function will never, ever, ever touch. Okay? How do you feel about rationals? Doable? Awesome. All right. Last, we have our word problems. I know you're so excited about it.